Hello student, welcome to the 8th lecture of magnetic circuit. Today in this topic we are going to discuss single phase transformer. So let us start. What is a single phase transformer? Transformer is a static device is used to transfer electric energy from one circuit to another circuit without any change in frequency and power. Look here. In this diagram you can see that in primary we have given AC input having voltage V1, and in the secondary winding we are getting AC output having output voltage of V2, but the level of V1 and V2 both of them are not same. So here you can say that a single phase transformer can step up or step down the voltage. In this circuit you can see that this is the primary coil which is input here, in which you are giving V1 voltage and I1 current flowing in the closed loop path of the primary coil. This portion is indicating your iron core, and in this iron core it have a secondary winding which have V2 output voltage, and in that coil you are getting an output current of I2. Now this is your next topic, working principle of transformer. Transformer is based on the principle of Faraday law of electromagnetic induction और म्यूचुअल इंडक्शन. आप लोगों से मैंने पिछले टॉपिक में भी डिस्कस किया था, पिछले लेक्चर्स में भी डिस्कस किया था व्हाट इज इलेक्ट्रोमैग्नेटिक इंडक्शन. अकॉर्डिंग टू दिस प्रिंसिपल किसी कॉइल में फ्लक्स फ्लो हो रहा है और वो कॉइल फिक्स है, बट उस फ्लक्स जो है उस फ्लक्स में रेट ऑफ चेंज है, मींस वो फ्लक्स टाइम के साथ वेरी हो रहा है. इस केस में उस कॉइल के दोनों एंड पे एक ईएमएफ इंड्यूस होगा. इसी का वॉइस वर्सा किसी कॉइल में फ्लक्स फ्लो हो रहा है वो कांस्टेंट है, बट कॉइल का पोजीशन विथ रिस्पेक्ट टू फ्लक्स बार बार चेंज हो रहा है. तो इस केस में भी उस कॉइल के दोनों एंड पे एक ईएमएफ इंड्यूस होगा. ओके, तो एग्जैक्टली इसी प्रिंसिपल पर हमारा ट्रांसफार्मर वर्क करता है. कैसे? When the primary is connected to an AC supply, a current starts flowing through it. The AC primary current produces an alternate flux phi in the core. When you are supplying V1 voltage and this coil is having a closed path, so a current I naught flow in this coil, and due to this I naught current a flux phi start flowing in this coil. Let's suppose this flux will be phi1. Here this coil have n1 number of turns. So due to electromagnetic induction principle, as you know that this applied voltage is AC, means sinusoidal, varying with time. So the flux produced by this AC voltage V1 is also sinusoidal in nature. It means that this flux is varying with time. So finally you will get an induced EMF E1 in the primary coil. Since this flux is alternating and linked with the secondary winding also, so induce an EMF in secondary winding according to the Faraday law of electromagnetic induction. Now let's see. Due to this V1 voltage, a flux flowing in this coil, primary coil, suppose it may be phi1. Now this phi1 is linking with this core, so a flux of amount phi is start flowing in this core. Look here, that flux is here phi. So in this coil flux is phi1, in this core flux phi is flowing. Now what is mutual induction? As you know that a coil having a flux, and that some part of its flux can be linked with the secondary winding. So the quantity of the flux which linked with the secondary winding is called as mutual induction. So due to mutual induction, a flux let's suppose it may be phi 2 linked with this coil, which is called as secondary coil, which have a number of turn N2. So flux induced in this secondary coil is, suppose it is phi 2, and it is linked in this coil due to mutual induction. Okay. Due to the primary current, due to the primary current, there is an induced voltage in the secondary winding due to mutual induction. Hence, the EMF induced in the secondary is called mutual induced EMF. Thus, energy is transferred from primary winding to secondary winding by means of electromagnetic induction without any change in frequency or power. Now next topic is types of transformer. Normally transformer have two types. First one is core type transformer, second one is cell type transformer. In core type of transformer we normally wound the low voltage winding and high voltage winding toward the outer of the core. Look here, in this core type we have wound this HV and LV winding at outer of the core. In this core type transformer we have wound first LV winding and then over it we have wound HV winding. Okay. Now in cell type we normally wound the winding at the center limb of the core. These legs of the core is also called as limb. Okay. Types of transformer. There are two types of transformer depending on the arrangement of the core and winding. First one is core type, second one is cell type. This is the equivalent circuit of core type transformer and this is the equivalent circuit of cell type transformer. In core type transformer, at the outer limb we have one primary winding and in the outer limb of that core we have also a secondary winding. But in cell type, in the center limb we have primary as well as secondary winding both wound on the same limb. Okay. Comparison of core type and cell type transformer. The core has only one window but the cell has two windows. In core type the winding encircle the core, but in cell type core encircle the winding. In core type cylindrical winding is used, but in cell type sandwich type winding are used. In core type transformer is easy to repair, but in cell type not easy to repair. In core type it is having better cooling, but in cell type cooling is not very effective. In core type less mechanical protection to the winding, but in cell type better protection to the winding. होप स्टूडेंट आपको ये लेक्चर समझ आया होगा. अगर फिर भी आपको कोई डाउट है तो आप मुझसे कांटेक्ट कर सकते हैं. थैंक यू.